right, Hardy Hay, shout out from West Virginia. And I'm still not getting it right, but that's okay, because I'm getting right joke of the day. So what is red and bad for your teeth? Red and bad for your teeth. A brick. That one makes no sense to me, but everybody else seems to love it. Anyways, but what we can agree on is solving multi-step equations. So we're going to take a look, and this is going to be in parts. And this first part is going to take a look at solving multi-step equations. They're going to be a little bit on the more simple side. But before we get into that, we want to recall one more time those two golden rules of algebra that say, remember that equal sign is the fulcrum that's in the middle of your pan balance. So that means that all of this right here is in this pan of the pan balance, and this right here is in this side of the pan balance. And that equal sign is that fulcrum in the middle. So we have to keep it balanced, which means what I do on one side, I've got to do on the other side to keep it balanced. The second of those golden rules says undo what has been done to the variable in opposite order, which means we're going to reverse our order of operations. Now, I've said this many times before, and I kept saying, but hang on, because this is only going to take one step, so we don't need to worry about it too much now. We're starting to get there. So let's take a look at these two examples. Now, one of the things I like about math is oftentimes it kicks back to something I already know how to do. We already looked at those one-step equations that said, okay, if I had maybe, for instance, an x minus 7 equal to a 10, we knew that all we had to do was add 7 to both sides. Or if I had an x plus 7 equals 10, we knew all we had to do was subtract a 7 from both sides. Or if I had maybe a 7x equals 10, we knew all we had to do was divide by 7 on both sides. Or if I had an x over 7 equals 10, we knew that all we had to do was multiply by 7 on both sides. I bring this up to say, okay, this looks a whole lot more complicated than what I have right here. But if I can make it look like any of these, then I know what to do. And my point in this is saying that in this equation I have variable, constant. And on the right-hand side, just a constant. But the whole point is I have variable, constant. And this one, variable, constant. And this one, variable. And this one, variable. So what I'm trying to say is if I could make this so that I don't have a couple of variables sitting here and I can condense it so that it's just one variable on this side, then I'm going to kick back to something I already know how to do. And so I'm going to go for that. So sometimes you might need to combine up those like terms first. In other words, shave down this side. Make it as simple as you can get it. Simplify the side and then take off with these other methods that we already know how to do. So in simplifying this side, what I'm going to notice is if I've got 4 x's in this pile, 4 x's in this pan, and I take 3 of them out, how many x's are left in the pan? Well, I have 1 x left in the pan. So the idea here is I'm going to combine up those like terms before I do anything else. So now I've got an x in there minus 5, and on this side just equal to a 9. But notice this looks an awful lot like we've got right here. I'm gold. I know exactly what to do. So to get that x by itself, we know that we're going to add 5 to both sides, and that'll give us x equals 14. Ta-da! There's my answer. And just like we said before, we can check this to make sure that it's right. So let's take that 14, let's plug it into the equation everywhere we see an x, and let's see if we can create truth. So when we check it, like I said, we're going to take this 14, we're going to plug it in right here, negative 3 times 14 minus 5 plus 4 times 14, and that better equal 9 in the end. Now our order of operations says do the multiplication first, so negative 3 times 14 is a negative 42 minus 5, and 4 times 14 is going to be a 56, and again we better get a 9 out of that. So now working left to right, negative 42 minus 5 is a negative 47. And negative 47 plus 56, is that a 9? Yep, it sure is. So we were able to create truth by using this number and plugging it in for those x's. All right, let's try another one to make sure we're real good at it. So once again, the idea is simplify that side. So let's even write this up here. Sometimes I need to combine those like terms first. Simplify each side. Simplify each side. because that will help a whole lot. It'll kick back to things I already know how to do. So as I look at this side, and I too, something else I like to do is I like to pretend like this equal sign. Not only is it the fulcrum in the middle of the pan, but it's like a wall. And it separates the two sides from each other, because when there's a whole lot of stuff like this, I tend to get lost. When it's as simple like this, I can see my equal signs pretty easy. But there's so much going on here that I can't see my equal sign anymore. So oftentimes I'll do that. I'll just say, well, there's my wall. So what I'm going to do is simplify the side. I'm going to shave this down, simplify that side as much as possible, shave this down, simplify that side as much as possible, and then I'm going to take off. So on this side, I'm noticing that I've got an 8y minus a 7y. So in that pan, I have 8 of these y's. I'm taking 7 of them out. How many of those y's are left? Yeah, I've only got 1 y left. Now, I'm also noticing that I have a 7 minus 10, and 7 minus 10 is a negative 3. So I have simplified that side as much as possible. I can't do anything with that y minus 3. I can't put them together. Now on this side, 6 and 4 will give me 10. So there's my equation, y minus 3 equals 10. So now in order to get that y by itself, once again looking very much like this, I know what I'm going to do is add that 3 to both sides, and that will give me y equals 13. There's my answer. And just like before, we can check this, and in order to check it, we know that what we're going to do is we're going to put that 13 everywhere I see a y. So I'm going to do 8 times 13 plus 7 minus 7 times 13 minus 10, and it better equal whatever that 6 plus 4 is, and we know that 6 plus 4 is 10. So we better get a 10 out of that. Now once again, with that order of operations, we do multiplication first. 8 times 13 is going to be 104. So we have 104 plus 7. 7 times 13 is going to be 91. And now we're just going to work our way left to right. So 104 plus 7 is going to be 111. 111 minus 91 will be 20. And 20 minus 10, is that 10? Yep, it sure is. So once again, we were able to create truth telling me, yes, that is the right answer. All right, let's look at just a couple more cases in this part 1, and then that will finish this one, and we'll move on to part 2 after that. So notice that in this one, here again, I like to put that wall up there to separate the sides. I cannot condense this side at all. That's as simple as it's going to get. Same thing over here. I cannot condense that side. It's as simple as it's going to get. But what I do know is that my variable is separated across the wall. Now remember, before what happened was, in these two cases, granted I had a lot going on over here, but the variable was only on one side. Same thing on this one, a whole lot going on, but the variable was only on one side. So I want to ensure that that variable is only on one side of that equal sign instead of being spread across that wall. So when that variable is on both sides of the equation, I want to get all the variables on one side, and I want to get all the constants on the other side. Those constants are the numbers that don't have variables with them, like that minus 3 and that 5. So here's the catch. It does not matter which side you get the variable on and which side you get the constant on. It makes no difference at all. Just separate them. That's all you got to do. Separate them. So we could take the 3r's, throw them over there into that pan, or we could take the 4r's and throw them over into this pan. It really does not matter. But in order to throw them into the other pan, you don't really pick them up and throw them in the other pan. The idea is I can take the 3r's out of this pan. And if I take them out of this pan, I have all my variables on one side. Or I could take the 4r's out of this pan, and if I do, I have all the variables on one side. But whatever I do to this pan, I have got to do to this pan. Or whatever I do to this pan, I have got to do to this pan. Make sure that those 2 golden rules of algebra, you keep doing that. Whatever you do on one side, you've got to do onto the other. So what if I decide I want to take these 3r's out of here? Because if I take the 4r's out of this pan, I don't have enough r's to take them out. I'm going to go in the hole here, and I'd rather not go in the hole. So instead what I think I'll do is I'll take the 3r's out of this pan, and that means I got to take 3r's out of that side as well. Now if I have 3r's and I take all 3 of them out, like literally in this pan over here, in my pan balance in this pan, if I had 3 of the letter R and I took all 3 of those out, I don't have any r's left. The only thing I have left is these 5 individual pieces. Now in this pan, if I have 4 r's and I take 3 of them out, I still do have 1 r left. And so here's what I now have. R minus 3 equals 5. That looks like the type of equation I'm used to solving. I know what to do now because I've got the variable on one side. That means I'm going to undo what's been done to that variable. I have taken it and subtracted the 3. I'm going to add 3 to both sides. And when I do, that will give me r equals 8. There's my answer. But just like before, we can check this to make sure that it's right. So when we go to check, we're going to take that 8, we're going to plug it right here where we see an r, and multiply 4 times 8 minus 3. But on the other side, we're going to multiply 8 here and get 5 plus 3 times 8. Now over here, again, follow order of operations that says do that multiplication first. 32 minus 3, and on this side, 5 plus 24. Now 32 minus 3 is 29, and on this side, 5 plus 24 is as well 29. We created truth. And when we create truth, we know that that's the right answer. All right, let's try one more, and then we'll be done with part 1. So similar idea here. There's my wall. Notice that I've got S's over here and over here. I don't like that. I want them all collected. So what I can do is either get rid of these negative 7 S's, but do that over here as well, or get rid of these negative 8 S's, but do that over here as well. And it does not matter which side you take care of. So I'm just going to go ahead and add the 7 S's here and add the 7 S's here. These will cancel, and on the left with a 20. But on this side, I have a 26. Now negative 8S plus 7S. I have a negative 8 plus 7. That gives me a negative 1S. But the good news is my variable is all here on one side. And remember, I've told you guys, it doesn't matter which side the variable's on. It doesn't always have to be on the left. It's okay. Just separate them and get that variable to have a coefficient of a positive 1. Positive 1 coefficient. So what I'm going to do now then is I'm going to say, well, let's get that 26 over to the other side. Let's subtract it off, giving me a 20 minus 26, which is a negative 6. And on this side, be very careful. The sign in front is the sign that goes. I've said that before. Sign in front is a sign that goes. It's like a name tag that's stuck to you. So whenever you go to a meeting, you put a name tag on, hello, my name is Lori, and you put it on the front. You never put your name tag on the back. That's just kind of weird. And if you put your name tag on the back, I have no idea who you are. I need your name tag on the front so I can identify your face with your name. So the sign in front is the sign that goes. It's the name tag for it. This is a negative S, not just an S. So on this side, I have a negative S sitting here. Now remember, I want a positive S. I don't want a negative S. So what I'm going to do at this point, we've looked at this before. I'm going to divide by a negative 1. And we know that dividing by a negative 1 basically just changes all the signs. So negative 6 divided by negative 1 is 6. And on this side, a negative S divided by negative 1 is just an S. So there is my answer. The S is going to be a 6. And just like before, we can check this to make sure that it's right. So we're going to take that 6, we're going to plug it right here where this S is. 20 minus 7 times 6. And we're going to plug it right here where this S is. 26 minus 8 times 6. So 7 times 6 is 42, so I have 20 minus 42. And on this side, 8 times 6 is 48. And so now 20 minus 42 is a negative 22. And on this side, 26 minus 48 is another negative 22. Once again, we created truth. So that tells me, yes, that is the correct answer. So hopefully this helps with the beginning. This is just the beginning of multi-step equations. And like we said before, the idea is you're still going to keep those 2 golden rules in mind. You're still going to do that. You're going to do on one side like you do on the other side. You're going to undo what's already been done to the variable. But you need to simplify each side. Collect up those like terms. Make it as simple as you can possibly get it so that all you have is variable constant. Maybe potentially on the other side, you will have variable constant. But once you've got it down to variable constant, now your goal is get all the variables on one side and all the constants on the other side. And like I said, it doesn't matter which side you get them on, just separate them. This up here, I had the variable on the left. But down here, I notice I have my variable on the right. It doesn't matter because this still says S is 6. 6 is S. It means the same thing. So it doesn't matter which side you get the variable on. So I hope that helps. Have a great day.